Okay, for what we have regarding section 1.6, we have for question number 1, it says to graph the expression, or I should say the representation of y is equal to 13/8 of x cubed. And what I can do here is I can just set up a table of x and y values. So I'd already have laid out, okay, like if x is 0, y is also going to be 13/8 times 0, which is 0. So we have for x and y, we're going to end up at the origin. Okay, so we have 0, 0. We have about right here. And for x equal to 1 and x equal to -1, so if x is 1, y is going to be 13/8 times 1, which is going to be 13/8, and you have about 1 and 1.625. So we have here, so you have about 1.625. So we have about right here. And when x is -1, we have the cube of a negative is a negative. 13/8 times -1 is minus 13/8. And as a decimal, we have for the coordinates, we have -1 and minus 1.625. So in this case, we have going the other way. So you have about -1, minus 1.625. Now, as you venture out further, okay, we have whenever x is 2. Okay, now 2 cubed is 8. 8 times 13/8. We'll have the 8's to cancel, so that will leave us with y at 13. So we have the ordered pair. We have at 2, 13. And we have for x at -2. -2 cubed is -8. -8 times 13/8 will leave us a minus 13. So we have -2 and minus 13. Okay, all right. And this is going to be a bit of a tight squeeze, but just in terms of taking what we have and just connecting. See, we have for the dots here. Okay, so this would be roughly the behavior of the graph for what we have is in reference to y is equal to 13/8 of x cubed. All right, now for what we have in the second item, okay, we have a parabola to graph, and we have y is equal to the square of x minus 2 followed by the addition of 1. So if I have x at 0, we have for y, 0 minus 2 is -2, square of -2 is 4, plus 1 is 5. And for x at 1, okay, we have 1 minus 2 is -1, square of -1 is going to be 1 plus 1 is 2. For x at -1, -1 minus 2 is a -3. The square of -3 becomes 9. 9 plus 1 is 10. For x at 2, 2 minus 2 is negligible. Add 1, so we have the y value that corresponds to b at 1. And if I have x at 3, 3 minus 2 is 1. Square of 1 is 1 plus 1 comes out to 2. So I have with the points, so I have 0, 5. And I have 1, 2. And I have -1, positive 10. Okay, so this is a bit of a stretch here. And then we have 2, 1. And I'm going to have 3, 2. And if I were to take any more points, say if I were to stretch out further, so you got with x at 4, 4 minus 2 is 2, squared is 4 plus 1 is 5. Okay, so I have 4, 5. And if I were to go out any further, say if I have x at 5, 5 minus 2 is 3, squared is 9, plus 1 is 10. So in this case, we have 5, 10. And in terms of graphing, okay, so we have with a parabola, looks like this one is going to be opening upward from 2, 1, and anything to the left and to the right of 2, 1, you're going to have end up with the left and the right half of this graph to end up mirroring. Okay, now, so this will be the appearance of y is equal to the square of x minus 2 followed by the addition of 1. Now, for what we have regarding the absolute value function, okay, so we have for y is equal to -4 times the absolute value of x plus 2 followed by the addition of 3. Okay, so if I have x at 0, okay, notice I have 0 plus 2 is 2. Absolute value of 2 is going to be at 2. Negative 4 times 2 is negative 8 plus 3. Negative 8 plus 3 is negative 5. So I had the ordered pair 0, negative 5. So we've got 0, negative 5. And if I were to shift over, say, 1 unit to the right, so I have x at 1. 1 plus 2 is 3. Absolute value of 3 is 3. Negative 4 times 3 is negative 12, plus 3 is negative 9. So I have, as an additional point, I have 1, negative 9. And with x, say, at negative 1, negative 1 plus 2 is going to be a positive 1. Absolute value of 1 is 1. Negative 4 times 1 is negative 4 plus 3, so I have at negative 1. So I have negative 1, negative 1 as the ordered pair. And if I were to go to x at negative 2, okay, and what is going to happen in this case? All right, so negative 2 plus 2 is going to be negligible. Add 3, so I have negative 2, positive 3. And if I go out to x at negative 3, so I have negative 3 plus 2 is negative 1. Now the absolute value of negative 1 is going to be positive. Negative 4 times 1 is negative 4 plus 3, so I have the ordered pair, negative 3, negative 1. Okay, and so we have, in this particular case, all right, so I have, again, negative 3, negative 1. And if I were to go out, say, even further, say if I have it with x at negative 4 plus 2 is going to be negative 2, but the absolute value is going to be positive 2. So I have negative 4 times 2 is negative 8 plus 3, so I have at negative 5. And say if I go out to negative 5 plus 2 is negative 3. However, the absolute value of negative 3 is a positive 3. Negative 4 times 3 is negative 12 plus 3 is negative 9. So if I throw in these two additional points, so I'm going to have negative 4, negative 5, as well as negative 5 and negative 9. So I got negative 4, negative 5, as well as negative 5 and negative 9. So we're going to have throughout. Okay, so we have with connecting the dots. All right, so we got, so these 7 points will be among infinitely many others that will represent the graph of y is equal to negative 4 times the absolute value of x plus 2, followed by the addition of 3. Now, for what we have for question 4, we got 2 parts here, and this is a bit tricky. Now we got for the graph of y is equal to f of x. Okay, this is what is shown, and it says to draw the graph of y is equal to f of negative x. So we have, just from the illustrations, I have 0, 0, like 1, negative 1, 2, negative 2, 3, negative 1, 4, 0, 5, 1, 6, 2, and 7, 3. So what I have listed in black, okay, so you have, so you got your x values at 0, 1, 2, 3, 4, 5, 6, 7 in the graph, and you got your y values that immediately correspond. And the only changeover I'm going to make is I'm going to keep the y value the same, but I'm going to change the sign of what I have for x. So as I go from x to negative x, the coordinates will be 0, negative 1 as opposed to 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, as opposed to their positive counterparts. And if I were to take what I have here, so you have matching negative x with what we have for y. So I have, once again, I have the origin, and we have negative 1, negative 1, negative 2, negative 2, and you got negative 3, negative 1, and you have negative 4, 0, and have negative 5, positive 1, and have negative 6, 2, and also have negative 7, positive 3. So you're going to have, in this layout, you're going to have halves that will mirror each other about the y-axis. And so just for the layout. Okay. Okay, so for what I have in red, okay, that's going to be the graph of y is equal to f of negative x. Now, for what I have in part B, what's going to happen here is in this graph I have y is equal to g of x, and just labeling in the black. Okay, so you have the order pairs. So I have 2, -6, 3, -4, 4, -2, 5, 0, and 6, 2. Now, in taking what we have in this layout, if I take the graph of y is equal to the negative of g of x, I'm just going to take the opposite sign of the y values. Where I had -6 originally, we have positive. In other words, where the y values were originally negative, and they correspond to g of x, negative g of x is going to translate to positive coordinates. And again, we have 0 is going to remain fixed, and where g of x corresponds to 2, negative g of x corresponds to -2. So we're going to have, so for what I have in correspondence to when x is 2 and y is equal to negative g of x, and we have 2, 6. So we have over here, so I have 2, 6. When x is 3, y equals negative g of x, it's going to have the y value of 4. When x is 4, corresponding y value is going to be at 2. And again, I have 5, 0. And when x is 6 and y is equal to negative g of x, that value we have at -2. Okay, and so that would be the result of what I have for that particular graph.